Welcome to lesson 3, problem number 1. Today we're going to look at solving inequalities in one variable on a number line. So when we do this, we really want to think about the fact that inequalities are very similar to equations. The only exception that we have to keep in mind when we're solving inequalities is that whenever we divide or multiply, if we divide or multiply by a negative, what we're going to do is we are going to flip our less than or greater than sign. Okay. Now, that would also be a less than or equal to and greater than or equal to sign. Other than that, we do everything just like we do with equations. At the end, we're going to actually shade the number line to show the solutions that work. Okay, so let's get started with this right now. And as we do so, let's just take a look. The first few problems will be a little bit more straightforward without fractions and things like that, but let's get started. I know you can see at the bottom, you can contact me anytime with questions, but for now, I'm going to zoom in so that we can get a good sense of how to do these problems. Okay, so let's get started where we are going to begin by adding 4 to both sides, just like we would do with an equation. So now we have 7x is less than 2x plus 20. Okay, we're going to now say, subtract 2x from both sides. And when we do that, we have 5x is less than 20. There was no need so far to flip our less than or greater than sign because we did not multiply or divide by a negative. Divide both sides by 5, and we simply are left with x is less than 4. So now I'm going to go to 4. I'm going to make it an open circle. I'm not going to shade it in like that because doing that would indicate that even the value of 4 works. But we only want the value of x being less than 4, not equal. So we leave that circle open. We're going to now shade because we want all the values of x less than 4. So we shade all the way to the left, even the arrow, because forever and ever to the left, all those shaded values will make that inequality true. Okay, let's go to the B. Okay, so right now we have negative 3x because we're distributing. You'll probably remember that from a previous lesson. Plus 15 is less than 30. Subtract 15 from both sides. No problem with that, but there's something interesting that's going to happen this time. Because now we're at negative 3x is less than 15, and when we go to divide both sides by negative 3, we have to remember to flip our less than or greater than sign. So we end up with x is greater than negative 5. So I'm going to still put an open circle at negative 5. It's not or equal to, but we're going to shade to the right because we had to flip that sign, getting x is greater than negative 5. Okay, let's go to C. So just like with equations, I'm a huge fan of first getting rid of any fractions. So what I'm going to do here is I'm going to multiply the entire inequality through by 2. We don't have to flip any signs because we're multiplying through by a positive. When we do that, we get 28 is greater than or equal to, now remember that 2 has to multiply everything, so 2 times 1/2. You could do it the long way and show the work, but I'd like you to just see those 2's cancel and you just get 1. So in this case, it's just 1x. So I'd like you to get to a point where you don't have to show that step. Okay, so we now have 28 is greater than or equal to x, and then the 2 has to multiply the 10, so plus 20. This time, I'm going to leave the x on the right-hand side, subtract 20 from both sides. Okay, and I get 8 is greater than or equal to x, which I like personally to write in a different way. So I'm going to put like a little arrow here to say that's exactly the same as x is less than or equal to 8. So you could write it like either way. They mean exactly the same thing, but I find it easier to actually graph the inequality when you have a variable, the x or the k or whatever your variable is on the left, because now we have x is less than or equal to. Notice I'm making it a solid circle this time, and then we can just follow the arrow and just shade to the left. All the values of x less than or equal to 8. Okay, let's go to the next one. All right, now we have variables on both sides, so I'm going to start by subtracting 3x from both sides, giving us 4x plus 5 is less than or equal to 5. I'm going to subtract 5 from both sides. No problem there. Little tricky though, because now I have 4x is less than or equal to 0. Now, once we get that, I'm going to rewrite that to just have plenty of space. 4x is less than or equal to 0. I'm going to divide both sides by 4. This is where you really have to know that 0 divided by anything is just 0. So x is less than or equal to 0, meaning any value to the left of 0, including 0, thus the solid circle, is a solution. And we're done. All right, I'm going to move this up a little bit, and always feel free to zoom back if you'd like. They get a little trickier here, so I'm going to give us plenty of space, especially with F, where we have a light bulb problem again. Okay, let's get started with the first one here. Just like with equations, we have these concepts where we need to first begin by combining like terms. 3x minus 8x is negative 5x. So negative 5x minus 1 is greater than or equal to 2x minus 5. Now it's just like when we solve equations, we're just always on the lookout for dividing or multiplying through by a negative when we have to flip that sign. Okay, I'm going to start by subtracting 2x from both sides. Okay, and when I do that, I get a negative 7x minus 1 is greater than or equal to negative 5. Adding 1 to both sides. Negative 7x is greater than or equal to negative 4. Divide both sides by negative 7. So here's where I flip that sign because I divide it by a negative. So x is less than or equal to a positive 4/7 because a negative over a negative is a positive, and we can't really do anything else with that 4/7. Now, one of the things you want to know at this point is that 4/7 is somewhere between 0 and 1. So I'm going to just put a solid circle, a little bit closer to 1 than 0, but anywhere in there, and you're just going to shade to the left because x is any value less than or equal to 4/7. So, okay, let's go to the next one, and this is a light bulb. So we are going to start by multiplying through by the least common denominator. In this case, I'm going to put a 12 on the outside. If you like, you can put 12 over 1. We are going to distribute that 12 to every one of those 4 terms. So 12 times 1 is 12. 12 times negative 1/4. You can do it the long way, but I'm going to take a little bit of a shortcut. I know that that means a minus 3x because 12 over 4 is just 3. And that's less than or equal to, same concept, 4x plus 5. And just like that, by multiplying through by that common denominator, we have made this inequality much simpler. Now let's just subtract 4x from both sides, simply because I have a slight preference for getting the variables on the left. So negative 7x, so 12 minus 7x is less than or equal to 5. We still haven't divided or multiplied through by a negative, so we do not need to flip the sign. Subtract 12 from both sides. Okay, and when we do that, we get negative 7x is less than or equal to a negative 7. Divide both sides by negative 7. And we get, I'm going to write the final down here, x, notice I'm flipping the sign because I divided by a negative 7, x is greater than or equal to 1. Because it's an or equal to, we make it a solid circle and shade to the right, and we are done. Great job. See you next time.